So, welcome back to this class on advanced textile printing technology. Let us see what did we do till the last or in the last lecture. We did learn about dynamics of aqueous inks. So, you remember that whether it is a disperse or it is pigment, they are all aqueous, they are suspensions or dispersions, or otherwise they may be soluble. So, in the dynamics we understood that there is an importance of surface tension, viscosity, and of course, the dimensions of the nozzle itself. And therefore, you have two numbers which we did talk about, Weber's number and Reynolds number. So, this is what from the inkjet printing point of view is an important aspect to remember. So, we did have disperse inks. The disperse inks can be used for printing of textiles, of course, and also can be used for printing of paper, which then can be used for transfer printing as well. So, if the dispersed dyes have to be used for transfer printing, their sublimation fastness has to be moderate. Okay. If they have to be directly used on textile, well, you will like the sublimation fastness to be high, as high as possible. And so, you can use dispersed dyes for printing the paper or printing the textile. Pigments, of course, pigment inks can be printed onto any textile or their blends. So, whether it is a cotton or polyester cotton or acrylic or what have you, you should be able to print using the pigment inks. But remember, both these inks are also water based inks. Okay. And we also remembered that today the binder is also part of the pigment ink. Okay. Only thing is which type of print head you may like to use, obviously not the thermal based printing jets. So, we have reactive inks, very popular for what? Cotton, of course, viscose definitely, and silk. Theoretically, obviously they can go on to nylon, no doubt, but you can have different types of ink, but normally they are being used for viscose, cotton, and silk. Of course, as we said, wool also can be printed in case you want to. And then acid inks are obviously meant for the nylons and silk, and if you want to print wool. So, this is what we learnt till now. So, more or less we have covered the advanced printing methodologies which are available today. So, what do we do today? Of course, we did learn about the pre and post treatments needed for each of these inks. So, the question next is, what do we do today? So, today in some sense it is a epilogue of finishing, giving a finishing touch to the whole course, and maybe a few aspects which we may not have discussed, we may like to just highlight them. So, what are those? We can spend some time on the issue of standardization. See, the whole engineering systems are based on standardization, whether standardization in terms of the inks, or we talk the machines or print heads and what have you. So, everyone must appreciate the standardization process, and we will just do a brief recall of whatever we have done, and then we will end this course with the hope that all those who have stayed with us for so many weeks would have learned something interesting, useful. So, we talk about standardization. There is no reason for anyone to believe that one can keep reproducing same quality as expected time after time, days on, months on, and can get the same effect. If you want to do that, then I do not know why should there be any question as to why standardization. So, everybody would like that whatever you see, whatever design somebody has conceptualized, this must be realized in actual terms on the textile fabric. And it requires a lot of hard work to make sure it happens. So, what kind of standardization are we talking about? So, we are talking about standardization of the ink itself. We may like to talk about the standardization of the hardware. So, let us say the standardization of dyes, which obviously in the inkjet context we call them inks, right, not dyes. Of course, they are dyes, but because the viscosity is very low and therefore, conventionally they are termed as inks. So, the ink. So, what do you want to know about the ink? We already know that we need these 4 types or inks for printing. We know what kind of a substrates they can be printed on. For example, dispersed dye is very suitable on polyester. Of course, other synthetic fibers can also be printed. Reactive dyes we just talked about, the cellulose based or a protein based substrates can be printed by this type of an ink. And acid dye based ink obviously is meant for the proteinous fibers, nylons and so on and so forth, pigments obviously for all types of substrates. So, this is what we know. So, what do we want to talk about today? What do we want to talk about today? So, let us say we know that this dye is a dispersed dye, but then is this the only thing that we were interested in? But inkjet printing, we are interested in the reproduction. So, what we are appreciating is the chemistry of the molecule. The chemistry is not just in terms of that whether it is water soluble or it is not water soluble, whether it is green or it is blue, no, it is more than that. What we are looking at in some way, as organic chemists would like to call it, the chemical architecture of the molecule, right. So, you have a dye which is going to be used to produce a certain type of ink, and so what is the chemistry, the actual architecture. So, this is what is going to be responsible. So, this is when you talk about standardization, we may be actually looking at that. So, we are quite sure, I mean there is no doubt, there should not be any doubt. You think there should be any doubt? If the chemistry is exactly same, the architecture of the molecule exactly same, the 2 nitro groups and 1 chlorine is exactly where it is supposed to be, then it is a standard molecule. Okay. Now, if every time we get the same molecule, we will get the same results, that is standardization. Then what are we talking about? I think we knew about it. So, in this architecture, we should be obviously concerned about chromophores, which obviously are most important component of a chromogen, but also auxochromes, which we know their purpose. They can change the tone. And so, all that together must be standardized. Well, somebody can ask, are we not doing exactly same thing every time? Of course, we are doing. Of course, we are doing. Then we make a particular die, we gave a CI number to that die. So, we are standardizing in some sense, and we expect that every time the CI number is same, the molecule in terms of the architecture, that means the chromophore, the oxychrome, the chromogen, the solubilizing group and everything else is going to be the same. So, that is what we appreciate, that we understand. What more are we looking at? So, when we talk about the inks needed for inkjet printing, sometimes we have said that we refer to as a digital printing. Yes, of course, because at the back end every information which is called a color is being digitized and then communicated through various hardware and finally to the print head, so that a design actually happens. So, if we said that every time we talk about a molecule of a die, we are very sure about the architecture and we are quite sure if you can reproduce that, you will get the same effect. What else are we expecting here? So, this is different. What is the difference? Inkjet printing, we say that we can create millions of shades by just 4 colors. I mean, that is the principle, isn't it? So, now you are not just standardizing any molecule, you are basically saying I am interested in 4 molecules which should always look the same, of course, but that is not the only thing you are looking at. Now, these 4 must somehow represent all the possible shades which you may love. We know how it can be obtained, but if there is any difference in a molecule made by one method, you are saying the CI number is same, but I am not still happy with the final result. The final result must be exactly same, and if it is not, then you may have an ink which looks very much similar to what you wanted to produce, but it is not the same. So, we are not just talking about any 4 colors, we are talking about the only 4 colors, the only 4 colors. So, that becomes a tough job. There the standardization will work if we are little away, and we will just see in which way we can be little away, then we are not going to get the same results. And that is also one of the reasons that not many manufacturers make inks for inkjet printing. So, what colors they were talking about? We are talking about sea, cyan, yellow, magenta and black. So, if these 4 colors of the exact specification, shall we say, if they can be synthesized, then you can expect the results to be same. It is not a question of that you can synthesize the same molecule every time, it is a question of whatever molecule you have synthesized is actually representing the hue, the tone of that particular color that you wanted. That is difficult, is not it? You think it is easy? That is difficult. So, this is what we call the true colors. Now, true colors, that means whatever cyan I wanted, this is the same cyan. If you make any other cyan with a little deviation, then you are not going to get the right results. So, the architecture of the die has to be modified in some various ways in order to get the same specification of the color. It looks easy to say, very difficult to do. So, if you want a real photographic print, of course, you want it. It can only happen if these 4s are true colors. So, you understand the true now? Yes. And of course, they must belong to different classes. I mean, they must be dispersed. The 4 dispersed colors which represent the CYMK, 4 reactive colors which represent the CYMK. Now, what is constant is CYMK. That is constant. The type of molecule may be different. And so, the important thing that we must appreciate is the standardization is in terms of those 4. And if that can be done, you are a successful ink manufacturer. So, somebody says, well, this is cyan, this is magenta, this is yellow, and this is black. Be happy. How do we know? How do we know? These are actually true colors. How do we know? So, one of the ways of knowing would be that you obtain an absorption spectra of these colors, let us say, and say, well, this is matching. If it is matching, then it is okay. I am not sure that whatever you are going to see after conversion of this video into the right compressed specification, and by the time you see it on your laptop or mobile, whether the color that I am seeing is what you are going to see. So, that means during this transmission of the information, which is digital information, the things can change. And if they do change, then the 2 people sitting at 2 different places may actually give you a different response to the same question. Are you seeing the right photograph? Somebody may say, yeah, pretty good. Somebody may say, well, not so much. And someone may say, yes, of course. So, but for a chemical manufacturer, the organic chemist, how do this fellow gets to the standard? They gets to the standard by looking at a spectrum. And if the spectrum matches, exactly matches, then you say, yes, I am there. This is what I wanted and this is what I have got. That is in some sense a very satisfying kind of a condition that you are very happy about it. But at least you have some way to say, are you there, are you not there? You make a dispersed dye, a yellow dispersed dye, you want to check whether it is yellow or not yellow. Well, if you can satisfy at least this kind of situation roughly, then you are quite close to what you want to do. But now we talk about quite close and actually close or actually being there. They are different stories. They are not the same situation. If they are not the same situation, you may get different results. So, we talk about a standard color, okay. So, that is standardization, a standard color. So, any company who claims that they have made a standard color, so CYMK standard. So, theoretically anyone can use those dyes, of course get to their recipes, of course they will do dilution, there will be a solid content, there will be other agents that you will add which will change surface tension, will change viscosity, that is one part of it. But at least you can say, well, I have in a way formulated ink and added water and other ingredients in addition to this standard color, and I am saying this is my magenta ink and I am selling it, all right. Of course, there is one interesting thing which one must not forget, and this formulation itself may have different viscosity, different surface tension, and therefore, some handshake must take place with, let us say, the printhead manufacturers, they must understand, but the standard color. So, let us say I have made a dispersed dye which satisfied the stringent criteria that we have just said, that is very stringent, to pass as a standard magenta. So, I am happy that this is a dispersed dye. Obviously, it is a dispersed dye, it does not dissolve easily in water. So, it has to be dispersed and it is given a standard magenta. So, what does it have? We have a chromophore and there must be some oxychromes which have been manipulated in a manner that we have got a standard magenta. Now, let us say I want to convert this dye into a reactive dye. So, what will you suggest? Well, select what kind of a reactive group that you want, whether it is a chlorotriazine based or you want a vinyl sulfone based or any other reactive group, and go to the, let us say, the synthesis table and add this group. So, it will become reactive dye. So, yes, everything else will remain same, a reactive group will be added. Let us say, so this dye has been converted to a reactive dye by attaching suitable reactive groups. So, from the chemical class, this has become a reactive dye. So, it will react and make covalent bonds with cotton in alkaline medium, with silk in neutral medium, and so on and so forth. All those things will happen. So, the question that should be asked is, will it pass as the standard magenta? You say, why not? I have not changed the chromophore, I have not changed the oxychromes, I may have added some solubilizing groups, or I have just added reactive group. So, will it pass the standard magenta? Will it pass? It may not. Let us see. So, we synthesize a dye which has a certain absorbance spectrum. Okay. Let us say this looks like this. This is pretty good. And now, this is my standard, and I have made a dispersed dye which was matching this. Now, I have done some changes to the molecule, exactly where I have not changed the chromophore, I have not changed the oxychrome, but I have added some groups. So, that becomes reactive dye. Is quite possible that what you get at the end of the day may have a slightly shifted absorption curve. The wavelength may, the lambda max may be different, the width of this curve may be different slightly. What it means therefore is, mathematically, digitally, this is not the same color. It is not going to appear the same. It will not appear the same. Let us say, you see these two boxes, hexagonal, they all, do you see any difference in the two shades? Do you see any difference? It is difficult to sometimes comprehend by looking at it, but if you go to a computer based color matching systems, you may say, oh, they are different. But let us say, even with the naked eye, if we take them little more close, let us see how it happens. Now, are you clear as to are they different or not? Now, I think they are clear, they are different. So, if similar looking colors like a magenta or a yellow or a cyan, slightly different, what effect finally they will have on a printed design. Will it be different or will it be the same? I am sure you know it. It will be different. And so, how do you reproduce? So, when you talk about standardization of inks of different classes, you will have to again rework on the molecule so that you come close to the standard. So, it's hard work. And if you have to do too much of a hard work, and purity is required, purity of the dye. You remember, whenever you make any molecules, so you have byproducts being made. You wanted to put a certain group, let us say a nitro group, on ortho position to let us say a carbonyl group, but you cannot 100% ensure that a meta substituted molecule will not be formed at all. So, what do you do? If you are quite sure that you wanted only ortho and everything will be fine, then you have to remove the meta. Obviously, it has very similar properties, various kinds of property, whether it's crystallization or its solubility and so much. So difficult to isolate. So, if you do make sure that they actually are separated and you get only what you wanted, the cost becomes high. Let us even forget the cost, but working for a particular molecule, changing the architecture in a manner that whether it is a dispersed dye or whether it is an acid dye or a pigment of some kind, inorganic or organic, the final result is the one which is close to standard. If that can be done, then you are in the game. And if you cannot, then obviously you will just have an image which may be different. It is okay. Then we also have to worry about, we not as a textile technologist, but at least those who are manufacturing equipment for us, they have to worry, but we must appreciate. Hardware and standardization, this also has to be done if we want a reproduction to be good. You have the right kind of a dye and therefore, you have a right kind of ink formulation, and you also seem to be having an equipment which can, you have a print head which can keep sending the droplets at the right positions, an interface also which works, so that whenever a yellow has to go, the yellow only goes at that time. The motion of the fabric or the print head are synchronized in a manner that actually the droplet falls wherever it is supposed to fall. All right. We have already understood the software algorithms must have made sure that this particular design, the color separation in these 4 colors is like this. Once you do that, after that you say, well, we are ready, but there is a machine standardization also. So, you have cameras and scanners which are going to give you the image, digital image. So, it is important that resolutions, obviously when the resolutions are going to be different, you are going to get different image, and so you can have problems. You can say, well, I know what is the image that I am wanted, I know what the resolution is required, and this is what is going to give me the right thing. So, you have everything else may be same, and still you have their processing algorithms from a company 1 to the company 2. You may not have, they may look similar, but exactly they may not be same. So, certain things have been done. Then when you take a picture which you think is the one which you want to print, in what lighting conditions did you take the picture? A little bit of a change in lighting conditions obviously changes the picture, and so it will be seen differently on a monitor, and if the picture itself is different, that was the information that you have, then obviously what will be printed will not be different. You already know the same dye which looks, or two shades which appear to be matched in sunlight, in let us say a different light, they appear to be different. So, lighting conditions have perceived difference can be seen when the lighting conditions change, and if camera has captured that, it may not be able to change the information by itself. Of course, there are algorithms which also later on you can change the background light and the adjustment of light, those software are available, but what you are doing is manipulation of some set. Whether it is true or not, one does not know. And what do you mean by true? True is what this eye sees, and whose eye? My or yours? Therefore, you have standardizations. Well, we have a standard eye and a standard observer, and therefore, a standard lighting conditions and a standard surface. You know, the same dye dyed on a twill fabric, on a chenille fabric, on a plain woven fabric will not appear same on a polyester versus cotton versus let us say silk. So, surfaces can also make differences, and therefore, whatever cameras or scanners will capture would depend on many things. So, you can have differences. If there are differences, the digital information is different, and therefore, final output also will be different. The display units, when you go to a shop for that matter, same picture is running on 4 or 5 monitors. Do you see exactly same in every monitor? You do not. Have you noticed this or not? Although they work very hard and they say, well, you have another way to manipulate, that you can change the contrast, you can change the hue, you can change the brightness. Yes, of course, but that is manipulation happening on the monitor. Other initial information is still the same. You are not changing the basic information. So, that means somebody has captured something which may be different. You say, okay, we are standardizing. Then you come to say what you see is may be different than what you saw. What you see in a monitor may be different than what actually was the design. So, some standardization processes must be followed, so that generally the protocols are such that most of the people will agree, well, this design is exactly what I am seeing on a monitor. If not, then you got to back calculate, do something if it is not true. Then the printer. Here what happens? There is a translation of this digital information through some actuation process. It goes to the textile and puts drops onto the surface. The drops get absorbed. Some of them can get absorbed more, some can get absorbed less. So, you may find that the effect which you saw on a monitor does not look exactly same on a textile. And how do we standardize? Well, they will like to standardize on a standard substrate. So, there may be a protocol which says, well, do it this. Now, at the back end, if keep, or in the front end, some will keep changing the substrate, I can't guarantee, but I will guarantee only if the substrate is this. So, you standardize printing systems based on certain standard things, some standard protocols, they must happen. So, what will be important for anyone in the standardization process is the calibration of the hardware. With the camera, some protocols must be followed. A scanner, some protocols must be followed. A display unit and a printer, all of them, if they are calibrated correctly from universal point of view, because now you say that somebody can give you or send you a design through electronic means, a digital information, and then you have to convert and correct things. If all of them are standardized in a manner that does not matter whether I print it in the US or in India, as long as the information that is coming is same, I will be able to get the same results. So how do we do that? Calibration. If so, you have standardized calibration systems, and if it does not actually come, then you must have somebody has to change the algorithm. This is not easy. So, it is a hardware based system, hardware plus software based system. That is how things will change. So, they have to follow protocols, and those are international protocols. All electronics people understand that. All need calibration for true color reproduction. I made a question mark on a true, because whatever we call true is supposed to be based on how I perceive through my eyes. And so, somebody has said, well, this is the, I call it a standard eye, and so if my eye is not standard, then I will see a different perspective, but that is okay. At least a large number of people, or at least the instruments will say it is the same. As long as the instruments say it is the same, you can still be happy about it. So, this is the final thing that we may like to agree, and that is standardization would help in color reproduction, no doubt about that. So, a translation from RGB values, again what we see converted also by many method of a design, whatever design that you have had, may have captured by whichever method you have captured, they have to be converted to, let us say, CMY values for a printing on a textile sample, an image. This is not a simple process, this also is a complex process. It would result in very unsatisfactory reproductions, because there can be variations in all these hardware elements, the input output devices. So, what input comes to the scanner, what input from the scanner goes to the display, what goes to the printer, what finally happens, all that if there is a difference. So, there is a difference. Therefore, what we have to do? So, must remember at least inkjet printer, the relationship between the RGB and CMY are complex, and this is not simple, no simple relationship, and therefore, one may have to obviously use software systems. Sometimes you may say, well, I use the AI to solve various polynomial equations or other nonlinear transformations, and keep checking it out. Well, by this whatever you wanted, it is coming, closer and closer. I think as engineers we appreciate when we say I have reproduced the same thing, I always believe that I have produced the same thing in the experimental error limits, right. There will be some error, and we must appreciate that. As long as my eye does not visualize the difference, then everything looks good. That becomes like a standard benchmark. So, all this that we just talked in a few last slides is surely not a job of a textile person. I am a user, somebody else has to do it, but I must appreciate. Then there is another interesting thing which we must appreciate, because of the CYMK not exactly being the same, particularly the CYM not exactly being the same in different types of inks. They may not truly represent a picture, right. If they do not truly represent picture, I still want, and one of the reason could be because I have not been able to make a molecule. I did tried very hard, but I could not make. But otherwise I understand slightly less orangish is there, still not coming. So, can I use an orange dye little bit to get to that point and then say, well, now perception will be correct. Okay. So, now people for true reproduction of color, again the true is a question mark. You will keep going towards that point, limiting to that true value. We can have more than 4 colors. So, you may have, depends on who are the manufacturers. You say, well, I will add a bit of an orange and I like to use yellowish red also, or reddish blue, or a yellowish green, etc., etc. All that can be. Why it is done? If the right kind of algorithms are used, so this information, the response from the additional colors would compensate hopefully the difference between the actual CYM, and then maybe it comes to a better reproduction of colors, and that is what being done. So, like we said, now you can have a inkjet color printing machine with 8, which uses 8 different print heads, colors, right. So, more than 4 definitely are being promoted, 6 is becoming almost a norm, 8 is getting really close, but the more and more colors you add, more and more complexities you have. So, all of them have to be standardized, but then you say, well, color gamut can be increased. Here I may like to just add, there is something called white. White. Why do we need white? You remember, sometimes we said, if suppose there is a dark background and I have got a beautiful design which got a light lemon tinge of shade somewhere in the design and I want to print on a dark background, you will see nothing, because the background is too dominating. So, how do you do that? So, one of the ways people you may have seen sometimes on a t-shirt, a white rectangular patch is first printed. On the white printed let us say the rectangle, you print whatever color design, light color, dark color, deep color. It gives a better reproduction and perception. Now, the softwares these days people are looking at, I do not like additional rectangle because that was not part of my design. Then what do we do? So, the software can help to print the ground with white, the textile surface with white in all those areas where any color is supposed to be printed. So, you will see no additional boundary outside the actual design. So, complex. The more and more you want to be accurate and true, the more and more the technology becomes complex, and this technology, you remember, has starts from the manufacture of the die to the heads to calibration and standardization of hardware. And of course, finally, here I do not know who has whatever control. The standardization would be with a standard substrate, but we know I will not be printing a standard substrate. I may have a bleached cotton, somebody has done a double bleach and somebody has not been very optimum. So, there is something called a whiteness index which will change. On a bleached fabric, somebody has put an OBA, so this will be different, and then you want to print a design on that. Synthetic, silk, plain, twills, all of them can, the texture can also change the actual perception, but then probably the user knows that my texture of the substrate is different, and so what you see on a piece of paper, the design will not exactly get reproduced. That probably will be an understanding, and if that is there, then it is okay. Otherwise, obviously, we know it will not look the same. So, what are we talking about? We are all engineers, isn't it? Engineers always appreciate design. Engineers appreciate the complexities. Even if a simple product, we appreciate because making a simple product today must have taken a lot of hard work by some people who made it simple. Today it is very simple. You get a printing cartridge for inkjet, you have a DeskJet printer at your home, put the paper, push the button, start printing. For you it was just a simple game. But those who made the ink, those who made the head, those who made the communication systems, the hardware which actually responds to your command, was a complex process. As an engineer, we must appreciate this. That is a complex process, and we should be happy about it, that we are also engineers. We are going to be solving many problems in life. Of course, whether it is printing or bleaching or making fabrics or what have you, others should also appreciate that it is a complex process. So, finally, the course is coming to an end. I hope you are happy. What did we do? In this course, we had three major components that we spent our time on. One was recalling the conventional printing, all right, understanding the difficulty of textile printing. We spent some time on thickening agents. We also spent some time in understanding the dyes which will be good for printing are slightly different than the one which could be used for dyeing for that matter. The chemicals to be used will be different, and of course, there are different styles of printing which you knew, but something like discharge resist style you may have not talked about earlier, but now probably you know, and for which kind of a substrate would you like to use it. Further, in the second part we had discussed transfer printing, which means majority of it is thermal transfer printing, because that is commercially successful, which requires a paper which is cellulose paper, which requires dyes which are dispersed dyes. They sublime, go to the polyester, get fixed, and so beautifully the designs can be transferred. So, we also understood what are the requirements of the dyes. We also understood the mechanism with which these dyes get transferred in a vapor form, and of course, we did spend some time on other methods of transfer printing, whether wet or relief, film release, and so on and so forth. Something we talked about the machines also. In the last section, we were talking about the inkjet printing, which people sometimes call it digital printing. So, we just discussed the complexities, complexity of ink, the dye, the formulation, the dynamics, the print head complexity, and finally, we talked about the standardization. What is the future? We began the inkjet printing saying, well, very less amount of percentage of the production, textile printing production happens through inkjet because of the cost of production, because the slow speed of printing. But in future, all this is being handled in a positive way. The cost of machine and a printing will come down, and you may see the next decade a good amount of printing is going to be done through inkjet printing, because this is for mass customization and not for mass production. It is to satisfy each and every individual rather than produce at a lesser cost the same thing. So, what is my hope? Hope is that you have learnt enough to get motivated to learn more about printing. Some of you actually had some, I believe, had some background of textile chemical processing, most of you may not have, and therefore, in some sense it may have been little harder to appreciate everything is going on. I hope the way we tried to cover this course was easy enough to grasp. In case you have difficulties, the advantage with this type of a course delivery is that you can again go back to the same video, keep looking at it again and again and understand. Wishing you all the best for your exam, and thank you for being a part of this course. All the best.